This is circuit diagram for IoT-based fire detection using the 8051 microcontroller with relay and LCD display. Here is the 8051 microcontroller standard circuit, using a crystal of 11.0592 MHz at the 18th and 19th pin and the capacitor, resistor and push button making a reset circuit connected to the 9th pin of the microcontroller. Please note that the microcontroller takes the input and provides the output according to the program. In the input side we have a flame sensor. And the output side we have a 16:2 LCD whose data pins are connected to port 2 and the control pins are connected to P3.7, P3.6 and P3.5. We have a relay which is controlled by the microcontroller through the relay driver IC. So when the microcontroller gives high logic to the relay driver IC, the output becomes low, allowing the relay to conduct and the load will get activated. We have connected our load and power supply between NO and the common point of the relay. When the microcontroller delivers the low logic, relay doesn't conduct and load will be off. On the input side we have a flame sensor. Flame sensor uses a comparator. When it's plus, that is the non-inverting terminal voltage, is more than minus, that is inverting terminal voltage, output will be high and vice versa. At the non-inverting terminal, we have connected the photodiode in reverse bias. So when the photodiode is connected in reverse bias, based on the light falling on it, its resistance value will change. This photodiode and 10K resistor forms a potential divider going to the non-inverting terminal. At the inverting terminal, we have a variable resistor to set the digital value. The output of the comparator is going to the microcontroller first pin. So when the flame is detected, the voltage drop across the photodiode becomes low. And in turn the non-inverting terminal becomes low. Thus, the output terminal of the comparator become low, sending a low logic to the microcontroller, which then acts as per the program and conduct the appropriate function. Here we have the power supply section. We use the step-down transformer 230 volts AC to 12 volt AC. This AC is rectified by the bridge rectifier, followed by a 470 microfarad capacitor acting as a filter, followed by a 7805 voltage regulator giving an output of plus 5 volt DC, followed by a 10 microfarad capacitor used to clear the ripples from the supply, which is then followed by a red LED for power indication in series with the 330 ohm resistor. In addition to this power supply, we also have one more regulator LM1117, the output of which is connected to the VCC of the Wi-Fi module to get a 3.3 volt supply. These are the connections for the Wi-Fi module. This is a ground point which is connected to ground, and this the TX pin which is going to the RX pin of the microcontroller, and this is the TX pin of the microcontroller is going to the RX pin of the Wi-Fi through this 100 ohms resistor and 3.3 volt Zener in it, because 5 volts of microcontroller has to be reduced to 3.3 volt. So the remaining voltage drop will occur across the 100 ohms resistor. When we switch on the circuit, Wi-Fi detects a nearby Wi-Fi router. When the flame is detected, the microcontroller will switch on the load and also send the data to the cloud through this Wi-Fi module. Hope you enjoyed the video. Thank you.